Welcome to the Blue Nuclear Pod, brought to you by Blue Capsule Technology. In this first episode, with COP28 a few days away, nuclear power's making the headlines again. We talk about nuclear beyond electricity generation, and why hard-to-abate sectors such as the chemical industry are on the radar for Blue Capsule and other nuclear startups here in France. To kick off the series, we're joined by Blue Capsule's very own Edouard Hourcade and Alexey Lokhov. Let's get going. Edouard and Alexey, thank you so much for joining us for the first episode of the Blue Nuclear Pod, fresh from the World Nuclear Exhibition in Paris, no less. But listen, first off, a few days ago, Bloomberg reported that actually multiple countries will lead a push at COP28 to supposedly triple installed nuclear capacity by 2050. So the US will, quote, likely be joined by France, Finland, Sweden, South Korea, and the UK. And they're going to call on institutions such as the World Bank to include nuclear in their lending policies. I suppose my question to you both then is, do you sense a kind of renewed optimism about nuclear energy as a technology? Or is this simply happening because we need all the climate solutions we can get and we need them now? Maybe Edouard, any thoughts on that?
Yes, I would say both, actually. We see that in one hand, we have a massive electrification of our consumptions, and we forecast that our electricity consumption will double in few years. So on one hand, we have this amazing tool, which is a nuclear power that is already ready to provide us with electricity. So this is pragmatism, I would say, to go on this direction. And on the other hand, there is an optimism concerning new technology, because electricity is one thing, but we believe that nuclear power can do much more than that. And heat is one of the way also to very efficiently use nuclear power.
Actually, on that, Alexey, Edouard refers to new technologies, and of course, the recent announcement made mention of small modular reactors, the SMR option. What do you make of that?
Yes, definitely. SMRs, it's something new and not new, because it's been some years already that we are talking about SMRs. So what's new is that new usages, as Edouard said. We are now not talking only about electricity, but also other services that could be delivered. And maybe they are needed in a smaller capacity than traditionally offered by large reactors. And this concerns heat, like in case of Blue Capsule, but also incineration of some of nuclear wastes, like with molten salt reactors. So all these new usages, they come perfectly well in the form of SMR, but it's also a new way of making nuclear, because smaller units can benefit from serial production, reduce to a strict minimum all works on sites, and that's usually what generates cost overruns and things like that. So making things small, factory produced to a certain degree, of course. Not everything can be produced in a factory conditions, but lots of things, and it's much easier for a smaller installation, smaller reactor, than for a larger reactor.
Yeah, no, thanks, Alexey. I think you're both very clear on that, on the promise of nuclear, not just for electricity, but for many applications. On cost overruns, I suppose we'll probably have to get into that in another podcast, because we have so much to cover today. But of course, I can already see some people asking about prospective cost overruns for SMRs in this technology. So that's something we should talk about, I think. My second question, I suppose, is more about the situation here in France, Edouard and Alexey, because right now, not at global level, but right here in France, in Paris, there's actually a lot of talk about investment in innovative low-carbon technologies in general, not just nuclear. Edouard, perhaps where do nuclear startups such as Blue Capsule fit into this broader picture?
Well, I think we are right in this picture. The French government decided 2 years ago that they would give a massive push to promote new actors into the nuclear industry and nuclear sector, and this is what's happening with this call of project called Nuclear Innovative Call of Project. There's something like €1 billion that is on the table to actually encourage new structures to emerge. And we're in there. Blue Capsule is a new structure. We are offering a new technology to to bring new solutions to existing problems, such as provide energy to chemical industries.
Okay. Yeah. No, thanks, Edouard. We'll get into that in a second. Alexey, just on the French context, I mean, how do you see this? What's your take on this? Because France isn't just interested in decarbonising an already very, very, very well decarbonised economy, but we're also looking at, I suppose, reindustrialisation of France and other economies.
Well, definitely, it's not the first time in history that France is looking on nuclear technology to solve all kinds of problems. Remember in the 70s when the oil crisis, oil peaks, happens. Well, that's where the turn to nuclear has happened in France. Today, and especially during COVID, people have realized that well, we are short on supplies from outside. We're dependent on external supplies. Well, the subsequent geopolitical situation in Europe has demonstrated that we are actually really exposed to risks of importing of various materials. And this concerns not only power, but also natural gas for our industrial plants, like all our ammonia production, everything else. So that's why there is this new interest. So nuclear today, with new technologies, with SMRs, can solve many other issues than just supplying power. So that's why there is this new interest and push from the French government to develop technologies. And this is something new. We haven't seen that in maybe 30 years.
Yeah, and Edouard, just to get back into what you were saying about Blue Capsule. I mean, what exactly are we proposing here at Blue Capsule, and why? Obviously, we're looking at the decarbonisation of industry. That's for sure. We're looking at more energy security, but why are we specifically looking at the chemical industry? What's our story?
In fact, chemical industries are major energy consumers, and when we think of energy transition, we think of electricity, and of course that's what we're doing with windmills, with solar power. But the sector of chemical industries cannot be is quite hard to abate sector in terms of how do we move from fossil fuel to electricity. This is not straightforward. So that's where we come in. How can we actually remove carbon from chemical industry that cannot easily use electricity? And Blue Capsule bring this solution that is very close to final consumers, and we propose something that is very efficient. When you want to bring heat to a chemical industry, of course you can create electricity and heat with this electricity, but then you lose something like 70 or 80% of the global power that you need in the end. Bringing nuclear heat close to the final consumer is saving major amount of power and energy. So that's this promise that we bring to consumer.
Yeah, thanks, Edouard. And Alexey, I mean, what does one module do exactly? I mean, what kind of capacity are we talking about here at Blue Capsule?
Technically speaking, one model of Blue Capsule can produce up to 150 megawatts of heat. This doesn't mean that it has to fit into one consumer, but that's the size of the unit that we have decided from various technical and economical considerations and market fits. And but in one phrase, it's 150 megawatt thermal.
Right. Okay. Thanks, Alexey. And who exactly is going to deploy these multiple blue capsules? Obviously, we've seen in the literature that this is for the chemical industry. What kind of end users are going to be interested in this?
Well, there are actually two questions in your question, because who will deploy and who will use. So, in fact, Blue Capsule is developing the technology, but we won't be operating the plant. So there will be an operator operating.
Sure. Yep.
Pardon my tautology, but the end users. So we aim primarily at the chemical industry, with some particular processes being very well suited for the output. One good example is soda ash, because they require high temperature steam at, at, at some pressures that are perfectly compatible with the output of Blue Capsule. And we have run some of the case studies for huge installations, and the fit is perfect. Other industries, for instance, ammonia producing plants, it's another good example, a huge consumer of heat. And also hydrogen, because, to make ammonia, you need hydrogen, nitrogen, and lots of heat and pressure. So all these can be produced thanks to the heat from blue capsules. It's very easy to plug into the synthesis parts of ammonia production, but also the heat output of blue capsule is very well suited with the temperatures required for some of the models of high temperature electrolyzers. So this is also one of the markets we aim at. And having power, hydrogen, whatever the sources of both, and heat, whatever the source of this. But having these three elements, an economy like France can be basically completely independent on all external suppliers of natural gas, for instance.
Sure. Thanks, Alexey. So obviously, this is what we mean by a polyvalent solution. So we're talking about not just heat, but also electricity and high temperature steam as well for these processes. Okay, thanks. But Edouard, I do have a question about the design and a question about safety because it's important. Could you just clarify firstly what Blue Capsule means when we say we use two technologies? I mean, how does that actually simplify the product? And also, if we could come back to the second point, why is Blue Capsule any different in terms of safety? So we're talking about chemical sites here. So obviously, I and others want to know why this product is safe to put there.
Okay, thanks for this question. High temperature reactors are not new. In fact, in the history of nuclear, they've been and they are high temperature reactors cooled by gas. And these reactors are interesting in terms of safety because the fuel is very specific, and the fuel, triso fuel, is so robust that nuclear core melt is intrinsically impossible. So your question would be, why anything new now? Because these reactors are not compact, and they are pressurized reactors. And they are very sensitive, potentially sensitive to external hazards. And this we don't want. We want compact technology that we can dig underground, so that any hazard coming from the chemical factory, for example, can be minimized. So the two technologies that we use is this one, HTR, high temperature reactor for fuel. And then to compact this technology, we use sodium. Sodium is extremely well-known technology here in the nuclear sector. It's been used for fast reactor for years. And it's very dense and a very good conductor for heat. And we use it to cool in natural convection the fuel. And with these two combination, we have both a safe and compact solution for heat and power.
Yeah, as Edouard said, it's a reactor core from a high temperature reactor, which have been used in many places. And we put the fuel from this reactor in a special arrangement, but we put it basically in the equipment that has been designed for sodium cooled reactors, and we put the sodium thermal buffer into it. So that's what we're talking about. So having all that in natural circulation, that means that we don't need any pumps. So this the coolant just circulates naturally. The reactor is operated, and it's intended to be operated at constant power. That's the preferred mode of operation of this type of reactor. But we will adapt the output, of course, to various needs. You don't have any pumps. You don't have any openings for the pumps. You don't need to take the pumps out to repair them, to inspect them. So this makes the whole system very simple.
Many thanks for that. So, one final question. Basically, who is Blue Capsule collaborating with to make this project a success? And what kind of organizations and companies are we dealing with here?
Well, Blue Capsule is part of a great team, which is the French nuclear industry, and this industry is very competitive and very skilled. One of the playground is Nuclear Valley. This is where actually we collaborate with other actors. One of the historical partners is CEA, which is a French Atomic and Alternative Energy Commission. CEA is a major actor and also a shareholder of Blue Capsule, a very specific partner for us, which is one of the founding partner who brings the sodium technology. But we also have major partners such as Aegis, who applied to this Lokhov project with us, and many other industrial partner, I would say. Elise Technology, which is another one, was developing a new technology for pyrolysis of waste. This is for the technological part. And then we have financial partners. We've mentioned BPI, which is the French National Bank for Investment. That is I would say bringing money for us to develop. France is one of the best place, I would say, to develop this technology because nuclear is in the genes of I would say of our industry. Yeah.
Thanks, thanks, Edouard. And Alexey, how about further investment? What is Blue Capsule doing to secure further collaboration, further partnership, and further investment into the project? And what does the future hold for Blue Capsule in that regard?
Well, it's very much linked, all these things that Edouard has mentioned and the financing side, because we are working with the supply chain to make these blue capsules possible. We are working with the end users to make this possible for them as well, because it takes also adaptation, and so these things have to be seen really early in the process. And we are very lucky to rely on the French nuclear industry to develop all of this. So this is for the partnership, of course. And then the partnerships are not only French, because to go outside, we'll also need some partners from outside. And today we're working with some of the engineering companies, like the engineering company in Finland, Platon, maybe you heard about that. So they have already helped us to have a Finnish view from the safety viewpoint on our design, which is very helpful because the approach is slightly different from the French one. But this is all, I would say, very natural for a nuclear project like Blue Capsule. These take some time to be put in place and to be established. And since it's a project between private sector, all these companies, and public sector in France, so we are supported through various mechanisms, including the participation of the French CEA. So that's the public side of it. But of course, we are very much interested in the contribution of the from the financial industry into this, so that it can complement all the efforts done by the public and industrial players, but that they could also benefit from the future production of these blue capsules for the industry. So we are, of course, very much interested in bringing the private investment into the project.
Okay, thank you. And just a final word, perhaps, from yourself, Edouard, as president of Blue Capsule. Obviously, with COP28 only a few days away, and with WNE getting started, World Nuclear Exhibition here in Paris, what is on Blue Capsule's radar for the next few days?
Of course, there's always a high expectation on discussion on climate mitigation devices. So we are expecting a lot from COP28 actors, so that new plans for decarbonization, including nuclear, of course, is decided and put forward. And here at WNE, we are preparing these solutions, and we are trying to make it real, so that governments and institutions can rely on us.
Thank you so much, Edouard and Alexey, for your time today. I hope you enjoy World Nuclear Exhibition here in Paris, and obviously we'll have you back on the Blue Nuclear Pod very soon. Thanks for listening to the Blue Nuclear Pod. You can follow Blue Capsule Technology on LinkedIn, via our website at bluecapsule-technology.com, and you can also catch our next episodes on any of your favourite podcast platforms.